Hello YouTube, today at PowerJack Repair we got an HP Spectre motherboard that's usually are not fixable. In this video probably gonna be about unfixable. There's an HP spare, it says right there. This looks like HP Spectre to me. I got the motherboard. On our website we basically state that we no longer fix USB Type-C connections for one simple reason. We do have a really good success rate when it comes to regular connections, like round power jacks, round, rectangular, you name it, 3 pins, 4 pins, whatever. But when it comes to USB Type-C connections, we could spend all day. We could do a really good job. And at the end, the IC chips won't work. Because what happens is when people start to wiggle this thing guy, and then wiggle this guy up, what happens, the proprietary chip like that one, could be that one, could be that one right there, they basically fry, and they are proprietary. So unless, and all of the used chips like that, you know, from donor motherboards, it just, you know, you could spend all day here trying to fix it. And I'm honestly not aware of anybody in the world who specializes in, who can, for reasonable amount of money, I mean, if money is not an issue, send it my way. I'm just kidding now. So the thing is, I'm not sure who will replace that guy, and those guys, and charge you a reasonable amount of money. So when it comes to HP and Lenovo's, once they started to make this stuff that only lasts about a year, that's pretty much the way how the business, I mean, how do you sell more laptops? You just make sure you're gonna install a USB Type-C connector on it, and in a year people gonna buy a new laptop, simply because this thing gonna go bad. So let me, now I know that it's probably not gonna work because I tested this guy, I tested that guy. None of them react whatsoever. I mean, usually when that happens, when no reaction happens, that means that guy that's responsible for a handshake doesn't want to work anymore with any of those guys. So the reason I make this video is so that you guys wouldn't send it to us, simply because again, when it comes to HP Spectres, I don't know, it's really time-consuming process. I could fix about 4 or 5 regular jacks in the same amount of time, and I can't really charge a client 4 or 5 times the amount it takes me. I mean, this is the flat rate fees. I mean, we don't call anybody, we don't bill anybody later, so to speak. Those are the flat rate fees, and that's it. But when it comes to USB Type-C, we just don't want to deal with them. These jacks, they have 2 rows of pins, one in the back and one underneath the jack. So the problem is soldering the second row. You can't really solder, you don't have the access with the soldering iron there. Soldering the rear pin, it's possible, but then the only way how the whole thing gonna work is if you gonna plug in, there is a top side and there is a bottom side to every connector, USB Type-C connector. So as long as you plug it in the top side up, the laptop gonna work and charge fine. Once you flip this guy over like that, plug it in, it's not gonna work because the second row is not soldered. Is it possible to solder the second row? Yes, it's possible. Now, is it possible to solder it in this kind of situation? It's not, because I'm pretty sure that once I put those guys, new guys in there, they're not gonna work. I'm just gonna attempt and put just one connector in. And if it works, great. If it doesn't work, then you know what, it's trying to do something about the second one is useless, totally useless. Do I have those connectors in stock? I don't know. Honestly, we have maybe 60, 70 different USB Type-C connections. What it takes time is to find which connector would go here. It takes more time for me to find which USB Type-C jack to install here than it's, in fact, to remove this guy and install it. Because those are tiny guys, I have to open each one separately and see, do they match. So maybe I will find something similar to this, maybe I will find something exact to this, but the reason I make this video is so that we get a lot more views from people who watch how the guy can solder half a day on YouTube and then eventually not get paid for anything, because I'm not getting paid unless the laptop works fine, and I'm pretty sure I'm not gonna get paid for this thing. But at least I'm gonna make a video and maybe gonna be some views, maybe people gonna subscribe, maybe people gonna say, you know what, bro, here's where you could buy IC chips, or that's the IC chip that I replaced and everything started to work fine. I would like to have a feedback, but I know there is a guy on the West Coast who used to do those, but he gave up too. Just like me, he gave up as well. And yeah, I mean, if I have nothing else to do, like today I have nothing else to do, that's the reason I'm working on this guy. But if you're busy with work, I honestly don't believe that this is worth. Hold on one second. Oh shit, doesn't want to work. Alrighty, so the first thing to do is to insulate those little tiny components right here. Sorry, wrong camera. Also wrong camera. Right here. So as you can see, those little black pieces, you're not going to be able to install them back on if you lose any one of those guys. And without those black guys right there, nothing gonna work here on the motherboard. So what you want to do is you want to put as much insulation right here, right there, as well as right here, so that you would not, and also insulation right here on the switch, because this is gonna melt for sure. All right, so what we do is we use a 3M product right here for insulation, and it's a high temperature tape, which is gonna make sure that none of those guys, I didn't expect there's gonna be so many on the other side too. Ay. Okay, so what I want to do is I want to insulate it from both sides, because as you can see there's a whole bunch of those guys, and if they fly off the motherboard you're not gonna be able to solder it. So that's the number one step. This is the Kapton tape. Kapton tape gonna lift those guys up, so you don't really want to use Kapton tape for those little guys, simply because, I mean, maybe depends how much heat you're gonna apply to it, but in general you don't wanna use the Kapton tape for this specific purpose, even though you wanna use Kapton tape all the time for all the other repairs, but this is just too minuscule. They're trying to be like Apple's product, but at the end somebody somewhere messes up. Yeah, okay, looks good to me. All right, so what I'm gonna do now is I'm gonna apply some thermal, not the thermal paste, the flux, liquid flux here and right there, and put it under the hot air, and this guy is supposed to come off and that guy is supposed to be coming off. Let me show you how to do it. Alrighty, yeah, you should be able to hear me here. All right, let's drop this guy down. Let's hope this guy is sitting there just fine. All right. Alrighty. Let's power everything up. I added some flux. Now I'm gonna add some solder. Once the solder warms up, it would be best if you would have something to Alright, so removing that one was quite easy. What you want to do next is put some silicon pad right here because otherwise the work surface is gonna melt. Alright, so here we're gonna add some okay. I guess somebody already tried to desolder something here. Alright. All the traces came off the motherboard. So when the yeah, no, I mean that second connector is for sure not fixable because you can see all the traces broken off the motherboard when people were wiggling it. So right here, as you can see, there are no traces left. So this jack is not fixable for sure. That's one of the reasons we don't fix the USB Type-C connections, because depends on how you broke it. That's gonna be the damage. And I can see some traces are missing on this guy as well. Let me clean up this guy right here. All right, so let me clean up that guy right there. I'm gonna do is I'm gonna add some solder right here, right there, right there, right here. All right, and once I added some solder, I will go with the desoldering quick and clean up all of the solder of the motherboard. All right, come on. All right, and that way removing all of the solder from the motherboard, prepping the motherboard for the new connection. All right, I cleaned it up from this side. Let me clean it up from the other side. All right, let's move this guy away right here. Let's make a solid surface here. And Alright, seems like there is a piece left inside from the bracket that was holding the jack down. Something big is stuck in there. Cleaning up those holes after the debris is really not fun at all. Let me get something right there. Alright, almost. Alright, so what the hot air does, it keeps the hole nice and hot while I'm trying to move the debris out of the way. Okay. Alright, so the good news is all of the pads are intact on one of them, and the other one, let me show you what's going on. I said, hey, what's going on? And I say, hey, 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 hey. Hey, hey, hey. I said, hey. Alrighty, as you can see right here, the reason we don't work on the USB Type-C connections because this trace is missing, that trace is missing, this trace is missing, that trace is missing, that one is missing, that one is missing. Some of those might be intact, but technically this one could work because that's not a big deal because we still got those ones. Now let me clean this guy up right here. That's the flux. Let me go in there with the desoldering rate because I don't want anything shorting here. Alright, so you see like that. Alright, good job. Well, yeah, the first row is good, but usually what we need is the second row because that's where the soldering gonna be just fine. I just wanna clean up everything here. Just in case I will end up putting the second connector, which not gonna happen because, again, no one in United States, nobody in United States is gonna be extending those traces. Yeah, so as you can see, this trace right here, it breaks right here and goes nowhere. There is no pad for the leg. Here, 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 here. So this trace is missing altogether. This one is right here, one right there, this one right there. So overall, I mean, yeah, in general, it's possible, but it's such a time-consuming process. For the prices, for the flat rate that we work on, this is not even worth the effort, because again, if the pricing model would be different, if the people would be paying, if insurance company would be paying for something like that, great. But there is no insurances out there that's gonna pay for this, because no insurance pays for the repairs. Now this is the one that's the side one, and all of the traces preserved here. So in those situations, usually the chances that everything would work are pretty high. But because we already have as you can see, every single pad is in place like that. You see, so this is the first one, this is the second one. That's the comparison right there, right there. So technically I could fix this one and it's gonna work fine. Also, I can fix this one. I got 20-something years working on these motherboards, but I don't think you can pay me enough to fix. I mean, you can pay me enough, but this is not a laptop that's gonna... It's not cost conscious to fix this guy. This one could work. This one, I don't know. But again, it's all about the IC chips. So even if I'm gonna be able to fix this guy, it probably not gonna work. More than certain it's not gonna work. Let me, shop around and see if I could find a connector like that in stock here, similar to this, and try and install it. Alrighty. After about half an hour of looking for the proper connector, this one looks extremely proper. Let's see if I can shove it in there. Alright. Did it go in? Yep, it did go in just fine. Now I don't see that the rear legs are touching everything fine for some reason. Let's see what the problem is. Why are they not touching the motherboard? That's wow, they're sitting up high. Something isn't right. There should be a solid connection between the board. Alright, let's try. Alrighty, so it turns out I needed to put a little bit more pressure on top of the connector in order for it to stay in place. Alright. Like that. I get comments, people asking, why would you spend $1,000 on a microscope? On a 3D microscope? That's why, because I can see the rear pins. If I'm like that, I can't see anything here. If I'm like that, I can see the rear pins, I can see the front, I can see the sides. And right now, what I'm gonna do is I'm gonna solder the sides first. Make sure they are nicely soldered. At the same time, I need to make sure that the rear pins are sitting in place just fine. All right, let's hold it. Ooh, okay, so it needs to be not touching the... All right, wonderful, beautiful. Just like slight tension. And right, what I want to do is I want to make sure that the rear pins are going to be touching the rear All right. Wonderful. Wonderful. Now let's do the sides. Nope, it's too far up. Okay. And probably too far up right here. So what we want to do is we want to flip this guy over. And well, for this kind of soldering, we don't really need the we don't really need the 3D stuff. It's gonna be like that, okay. Well, I need to put it onto something so that against the, all right, good. Let's do like that, let's do like that, and like that, okay. Alrighty. Okay. And okay. All right, so what I want to do is something like that, something like that, something like that, and like that. All right, so the connector is soldered in. All right. Again, this is a 2D, and this is a 3D. So you can see we soldered on this side, but we're not soldered on that side. So what I need to do is probably, you see the tip of the soldering iron is a bit too big to fit right there. I see. Doesn't want to get in there. All right, so it's no problem because I got a much smaller tip. You see, now it's good. Can I put this guy in there? Yeah. All right, so now the goal is right here. You can see that all of the black pieces are in place. They are not destroyed in any way, shape, or form. They're like that out of the factory. And I need to do a solder on each one of the rear pins. Now, unfortunately, I don't advertise flux because this is not the best flux there is, but at least this is the least toxic flux because I do it all day, every day. I prefer the least toxic flux possible. All right. So I think only one that's not soldered well is right here. This guy. Those are grounds usually. They are hard to solder because this is the soldering iron that's made for something like that, like that, like that, and right here. I'm looking for a smooth connection. which this guy doesn't give me. All right, now it's giving me the smooth connection. All right. So the way how I check it using this I know this is not a lint-free swap, but we got shortages nowadays. So this is not a, this is what we have to use. All right. Now I'm not 100% happy with that one last pin there and there. And again, that's the reason why we have a 3D microscope right there. You see the last pin and the last pin, they don't have the best smooth lines in there. So I will try and add a little bit more solder there. All right. All right, and let's try and put more solder onto this guy here. All right. Now it's possible to do it using the hot air. The only problem with hot air, all of the black components in the back of the connections, those guys, they're all gonna fly off the motherboard. That's the reason I don't use the hot air here to... So you see, I can do a beautiful job, all right? I can fix it. So some people keep saying, oh, you can't fix it? I can fix anything given enough time. But I'm pretty sure that this is the most useless repair there is. Let's see if we're gonna make it work 50% of the time. Again, as I told you, the inner row is not soldered. The outer row is soldered. And this is brand new jack. That's front, that's back. Wow, that's too high for me. Here, like that. So what I'm gonna do, I'm gonna clean this guy up right here as well. And we're gonna power up the whole board in a second and see if the IC chips are bad or if IC chips are not bad. Hopefully we're gonna be able to make it work. All right, the exhaust fans are super loud and my voice always gets, well, basically there's a filters that filters out my voice from the, here, by the way, let me show you. So everything is usually muffled up a lot. So like that, like that, like that, okay. So in theory, if the IC chips are good, if they're good, the system should show me some light. Should give me 20-volt handshake. It should show me 5 volts at first, and then it should show me 20 volts later. I'm not sure if you just heard it. Yeah, you heard it. Okay. So for that, I have this guy right here that's supposed to measure. I mean, I have a whole bunch of them. Some of them are already fried from overusing them. So let's see. All right, so we got, all right, so this one goes in, and let's see. And nothing. It's a brand new jack. Now let's flip this guy over. Oh, we got 20 volts, okay. But the amperage is 0.01 amp. 0.01 amp means nothing good. It should be a lot more, but the handshake happened. So the laptop will power up probably, but again, that's 0 amp. That's usually it should be like up, should be more than, but the handshake happened, the board should power up, because if the handshake would not be happening, we would not be seeing 20 volts, we would be seeing 5 volts, so we would see nothing. So the upper connections are going through, and again, if you flip this guy over like that, connected like that, you see nothing, because again, this is the top side right here. We're gonna plug it in and it's gonna work. Again, handshake was happening at 8 volts, then it boosted up to 20 volts. So wow, yeah, I didn't expect it's gonna work, but it will, only when you plug it in the right way. Okay, all right. With the second one, it's not gonna work probably because of too many, well, no, yeah, well, hold on. Yeah, well, let's see if I could solder the second one in place as well, because since it's here, maybe it's gonna work using the 5 pads in the back right there. Maybe this one is a bit damaged right here, and yeah, so I only need to solder 1, 2, 3, 4. It's probably not, because the thing is, there is a data needs to exchange. So this guy needs to send the 5 volts first, then it needs to receive a signal back, and then it needs to boost the voltage to. Alrighty, so it would be interesting if I put the second one. That's another connector that we got here. I need to do something about the damaged board right there. So if I'm gonna put this guy in there, will it work? No, I'm not gonna bother. I mean, I'm not gonna waste your time showing you how I'm trying to solder this one. You just seen how I tried to solder that one. So let me just pause it right here and see what's gonna happen. Oh, again, that's the damage. Let's see if we can kind of try and do something here. Well, can't really do much with the soldering iron there. Well, maybe I could just melt it down a little bit. Like that, the trace should be intact. Alright. Alright, let me bring my cards. Alright. So I cut the board a little bit right there. Now I want to make sure that the new connector should fit in just fine. And I just lost the new connector someplace. Okay. Oh, I need to remove the rear bracket. All right, something like that. Okay. So let's solder the sides, just like we did before. Alrighty. And let's do, how would they hold it down? Need this guy to slightly rotate, to do some sort of rotation this way. You see, for some reason, it's not, oh, maybe like that. Okay. Oh, come on. Here, let's do that. All right. Nope, you see it doesn't want to pick up. All right. So let's do this side too. All right. Now let's do the bottom. All right, like that. All right, I just don't want to have any excessive solder right here. All right, let's flip this guy over and see what we got. We got a beautiful picture. Yep. All right. How many we got here? 1, 2, 3, 4, 5. Yeah, let's do. I will be extremely surprised if it's gonna work on those 4 soldering points. Shoot, I shorted the 2 components there. Let's try and de-short it. All right. Oh, come on. Nope. It should have been easy repair. Easy. Instead I got myself into a mess. All right. I'm not sure if I still have a short there or not on the between the leftmost and the second. Let's see if I have a short there. Is that a bridge there or that's not a bridge? Hard to say. Let me use a yeah, really hard to say. All right, I just need to finish up soldering here. right? And finish up. Soldering there. Okay. Good job. Good job. Alrighty. Let's hope. Let's try and dry things up. Alrighty. Let's plug in the device that shows nothing. Let's flip it over. And nothing. Alright, so again, yeah, I mean, I saw that the 4 connections are not gonna work, but I still went ahead and tried to replace it, and nothing. Okay. Alright. Thanks so much, guys, for watching. Please leave a like, subscribe, and I mean, there are ways to fix those traces, but again, the client sent $60 to replace the connector, and I mean, for $60 replacing 2 of those guys, fixing the tracers, it's a whole day job, guys. It's not really a 5-minute thing. And if I would charge more, yeah, I could fix everything to work 100%. But then we go into the territory where, you know, where client doesn't know how much I'm going to charge him. And that's the reason we just say, you know what, don't send us any USB Type-C work, because it could be anywhere from an hour, like this video, to half a day. So yeah, I can't just say, you know what, I'm gonna charge the client whatever I think I'm gonna come up with. So yeah, thanks so much for watching. Please leave a like, subscribe, and if anyone knows a good way to solder the inner row, please leave a comment below. I would really appreciate it. Thank you. Bye.